All right, you need some help. That's totally fine. This video is going to seem a little strange because first I'm going to go through a little bit of a presentation and then I'm going to switch to narrating mode. So what I did is I actually hacked up the server. It's mostly real time. What I did originally is I sort of took a lot of notes. I figured out what I wanted to do, did like a quick little, what they call a spike, a little hack. And then using my spike, I basically built the whole server over the course of the next 4 videos. So this is the one where you see me first get up just a little echo server. Okay. The video is sped up. When you see me coding, I'm actually not that fast. Okay. It's sped up 150%, maybe even a little more. I gotta crunch these down, and you can pause them when you want to see me do stuff. So there's no point in me having it go at normal speed. And then also the videos are recorded with no audio, and I'm not actually typing. Like you won't hear me typing, and you won't hear anything. I'm going to narrate. So I'm going to basically do a narration of what I did and what I was thinking. So you get to see me make mistakes, do all sorts of other stuff. And this is a little more realistic because it's me actually coding like I normally would. I don't talk to myself really when I code. And then I narrate afterwards. Okay, so the purpose of this video is you watch me the first project quickly, and then I review the code a little bit. First, I need to install liblcthw. You'll see me do that, and you should already have this installed. Then I make a project skeleton, and I get something going, anything going. Then I just get the server accepting a connection. That's it. That is actually really, really difficult. I actually had a hard time with that. So keep that in mind. I've been coding C servers for decades, and this was still difficult. I still had to look it all up. So, make sure you don't beat yourself up if you couldn't figure that part out. Then I decided just to make it echo back what I type. That's a basic sort of thing. That's what you have to do. That's pretty much what a server is. Most servers are just more complicated echo servers. Okay, so here's the final code. Watch me code this up, and you'll see that it worked out pretty okay. Okay, so first thing I gotta do is I'm gonna run a program called Screen that gives me like multiple terminal screens. There's another program called tmux that does that. Okay, and then the next thing I got to do is install liblcthw, learn C the hard way. It's a library we made, so we're going to use it. Once that's installed, then I have to copy the C skeleton over, and I have to go through the process of gutting the C skeleton. All right, so it's all cleaned up. Now, first thing I have to do is edit that make file. And it's just a simple process of going through and converting each of the things over to statserve itself. One thing to remember is I would probably do this a little differently. I would say just create a C skeleton that had this all gutted and ready to go instead of doing all this work every time I want to start a project. Remember, it's all about cutting out friction. Okay, so I've converted the files over to be named statserve, change the test, make sure that it runs a bit. And notice that it complains that it's missing files, and that's totally fine. Okay, so once I have those files gutted, this is what I'm doing now. I gutted the other one, and now I'm gutting the test. And it's mostly just to make sure that I have a clean slate to start. So that's a simple way to do it. Everything runs. Cool. There was sort of a mistake in the make file, and I fixed that up later on, but it makes it so that I have to constantly keep doing make clean to get the test to run. And I just didn't have time to stop and fix it at that moment. Okay. So now I know I have to make a function called echo server. So like I taught you, you just make the bones and then you put the skin on, or the muscles and then the skin on. So I've created an empty echo server. Echo server function. And then I have to go and make the main So once I get the main done, I want to change the project over to use the libc the hard way debug file. So I have this debug file that was in there, and I don't want it in there. I want to use the one from the library. So if I'm just starting simple projects, I'll just leave the debug.h in there, but actually I want to use the one in the library to make sure that I'm using the same one everywhere. Okay, and then I make a simple bare bones main, get that all working. And I have to update the makefile to include all the libraries and everything. And I believe I have to add the bin statserve target, make sure that it depends on the target library. And I also have to make sure that works. Yeah, get rid of the debug.h that's there. There's a few more places I seem to have to include it. And then I found that there was a problem. For whatever reason on OS 10, user local directories aren't automatically added by the compiler. So that's a little annoying. So I have to augment some of the flags. So that way I include the library flags and include user lib in that. And then I have to update how things are built so that way those options are added. But that's a pretty simple, straightforward change. I add the new variables up there. I find the SO target so that way it can get linked correctly. And I add add the options to those. And that should be about that. All right, so now it's building. And still have some leftover debug.h's. Change the one there. There we go. Now it's debatable using the one from learn-see the hard way versus the one that's there, but since the lib learn-see the hard way uses it, I want to make sure that I keep just one. Oh, and then I have to add it to the all target so that way it gets built. Okay, so that's building-ish. There's nothing in it, so it just builds real quick. Okay, now I just have to get that server accepting a connection. It seems simple, but it's actually kind of difficult. So, just gotta go through the code. So first thing I want to do is remember I have the net client from exercise 44, and that has a whole bunch of stuff ready to go. And keep in mind that this process right now is I'm in creative mode. So remember we talked about creative and destructive. So I'm just getting something together as quick as possible. Don't worry about being correct or any of that stuff. I'm just getting it together, just getting it to work as fast as possible. And to do that, I'm going to use code that's sort of lying around and get it up and running. So I might need the non-block. Maybe I'll just have client connection there because I might need it. I'll definitely need read some and write some. That's a definite. Okay, and so then I do the usual pattern. I get net.c to go, and then I get net.h to go. I would also spend the time. At the video, I can't do as much of this because I'm showing you how to write the actual software, but I would spend the time to then also write an automated test for net, so that way I could make sure that it worked reliably. So if there were errors, I knew if my tests were passing for net, the errors had to be in something else. Okay, so net.h is building, and because of our fancy makefile, it's automatically being included in the library, and that's all we have to worry about. Now, I'm going to make the main just run that echo server. And this is a common pattern I use. I make a library that has all the real code. And then I use main is just nothing more than a lame shell that sort of sets it up and gets it going. And this works out a lot better because what you end up having is if you're using a library, then you can actually test it a lot easier in C because you can just load the library into your tests. It also means that you can actually reuse this code in other spots and other places, make different binaries that people can run. It just saves a lot of trouble rather than putting tons of code in this main here. Okay, so now the main function is just running the echo server, and I have to change it up. I'm realizing I have to pass these parameters to it, so here we go. And the code just kind of writes itself. Like, I start with main. I know that I have to pass these to it. I go over to echo server, so on and so forth. This also works the same way when you do tests. I write the test. I know that's how it has to work. I go and I actually update the code for it and so on. And notice I'm filling in the error stuff. I'm indicating that it's fall through, so on. Okay, so just here I realized now I need to add the H file for statserve. Pop that function in there, and now it builds. Cool. Now it's running. It doesn't do anything because Echo Server just doesn't do anything. But at least it runs and it pretends. And notice my pattern is the same. I just get stuff running. I just get a little bit running. Remember, it's climb the mountain, don't jump over the mountain. Now I need to figure out what to do. So a lot of times I can just write the code, but I'm doing it more to demo what you need to do and also just to keep track. So I'm writing comments. So I need to create a SIG action that handles SIG child, listen on a given port, accept the socket from the client, fork, and then if I'm in the child, and never mind my spelling, then it's the server. Okay, so I do that throughout all the videos so you can see what I'm about to do, right? So instead of a presentation, I write these comments. But you should just write your code this way for a long time. In fact, when I did the quick hack to see how I could write this program, I didn't do this, and it was actually harder. I should have done this, and I should have also leaned on tests a lot more. Oh, and by the way, the reason why I'm talking about the SIG action and SIG child is if you researched fork, especially if you were going through Beege's IPC and how he does fork and all that, you'll know that you have to set a handler that when children die, you wait on them. It's sort of a Unix thing where you have to create a handler that knows when children from forks die to do this. See this wait PID here? So the wait PID is basically how you reap them, how you collect them. So it's almost like you have to garbage collect your forking. Okay, so once I have that, then I do the rest of the stuff for setting up a SIG action. You have to empty the signal mask. You then have to register the handler with the SA. No, you have to set the signal you want. And then set the handler, yes. Because see, up there, SA handler is set to SIG child. Okay, and clearing this out because it kind of has to go after variables. Remember, if you do your check before variables, you run into problems with the compiler saying that the variables aren't initialized at the certain points. Okay, I forgot some includes. Sometimes you can find an include that just seems to handle all of them, but I also tend to just sort of like, I know these ones, so I just, I just write them out. You'll also notice that I sit there and I write the functions, and I go and I look at the function formats, but, I make mistakes pretty frequently. And you'll see me just sit there and make a mistake, but, I sort of know I make mistakes, so I have ways of double checking my work. Like, the compiler runs, I have tests, I do code review, like you saw me do in all the previous videos before this. Okay, so now we have a signal handler. It doesn't seem to do much, but you'll see if you don't have the signal handler working, you can have, like, you'll run lots of connections, and then you'll have child processes leaking. All right, so once I have that, now I need to make my listening function. So if you've been doing your research, you know that there's a certain process to making a listen function. But again, you write the bones, then you put the muscle on, and then you add the skin. So the bones right now is just a function I can call. That's all. There's also an interesting problem. So it's sort of universally difficult to do unit tests on socket stuff in C. Other languages you can fake out the sockets, but in C it's kind of difficult. So I don't really do a lot of unit tests for this part of the code. I more just use the server from the command line. If I were to automate the test, which I probably should have done, I would just have a bash script that ran things, and I would set a few options so that way I could make the server run maybe like 10 cycles and then feed it some data. Okay, so now I'm filling in what we can call the muscle. I got the skeleton. Now I'm saying, okay, here's the muscle. Get the address info for the host and port that they want to connect or listen on. Cycle through the available list to find one. This is a thing that has to happen in modern network programming because you can get lots of possible addresses for the same requested address. So you're just going through that. That's pretty much just the documentation for that one function, address info. Tells you all that stuff. So now I have to set up a few pointers in order to do that for loop. And I need an actual address to start with. And these are sort of options that say, yeah, I want this type of socket. I don't really care what, family, and it's passive. Oh, and I've misspelled that, so I have to go back and add that. All right. And it's fine to have unused variables while you're working on this kind of thing, because remember, you make the variables and then you go and use them. Okay, so following along with the documentation on the man page, which is sort of off to the side, right? So you don't really see it too much while I'm coding. I have a reference off to the side. I do the get address info, and notice I'm doing the address of ADR variable, and info is an address, but it's a pointer. So I'm getting, basically setting these variables up according to the documentation. Read the man page. And then I'm going through each variable. See that next pointer? So you get kind of a linked list. Remember, we studied linked lists, so that's what you get. And then I attempt to listen on it. And if it works, if it doesn't give me a -1 from my attempt to listen function, then I break out, I found one that works. If not, when I'm out of this for loop, sockfd will be -1, and then I know I can abort. Okay. So all of that is pretty much just to get a socket to bind on and listen to. But we still have one other function that we have to write. That's the attempt listen up there. You'll notice I also have a common pattern of, I know I need to write a function that does a certain thing. So I'll make a function. Instead of like writing the code right there under that comment, I just said, okay, I'm going to work on that function. And then I can sort of just pretend that function works for now. Now what I do is I write the attempt listen function, and the attempt listen function is going to need to use the socket function, set sockop, get sockop, bind, listen, not accept though, because accept is going to be in the echo server functions loop. Okay, so I set up attempt listen with its skeleton, just getting it there, and then I'm going to fill in the muscles and sort of like describe what I want it to do. So I'm reading my docs, so that's what I'm doing when I write these. I got to create a socket with an address info. I got to set the SO reuse address. If you don't set that, then the server can't bind. Attempt to bind to it, and then listen with a backlog. If the bind works, then I should be able to do a listen. Okay, so I just make a socket. Oh, and I want to make sure that info doesn't equal null. In my quick spike that I did, the info, sometimes I passed it incorrectly. Okay, so if that works, that bind works, then the for loop that we use to call this function will work. But otherwise, we just abort because we're rolling through a list of possible addresses and trying to bind them. And, because the OS gives us these, here's a possible list of addresses for what you asked for. So we're just basically rolling through them. And if this function returns true, then we're good. Okay, so the next thing is we got to set the sock option. And I'll explain it again really quickly. If a server dies and you want to reconnect to the port that was asked for, the OS assumes that you can't do that for some reason. So you have to tell it, yes, you can reconnect if nothing's on that port. All right, so now we try to bind to it. So remember, the process is get a socket, set your options, bind that socket. So that way you get a bound socket, and then you listen to it. And when you listen, you have to say like how many pending clients to keep in the backlog, because the OS will keep them waiting while you're trying to do processing. Okay, and I don't like that magic number there, so I'm just going to go over to the header file and toss in the backlogs. I could also just make that an option to this function. Oh, and I need to include my own header file. Okay, cool. Yeah, I could make that an option to the listen, but a backlog of 10 seems to be fine. And actually, when I do the critique of my own code, you'll see that I actually don't like the forking server option at all. Okay. And that seems to start up. It doesn't have any errors, and there you go. Oh, I haven't even called that that listen function. Okay, so now I can call that function. And I have my little server socket, host and port, and there we go. Okay, that compiles. And notice it's a very methodical process I'm using. I write a comment, I figure out what each part of the comment needs to do. I go write a function that sort of matches the comment or a bit of code, and then I basically fill in the blanks. And then each comment basically works as a to-do list, kind of. So there we go. Now, sometimes I keep the comments around, but a lot of times I don't. Oh yeah, my debugging wasn't being printed out, so I had to find all the places that ndebug was being used. Yeah, and I want to undef that. That's fine. Okay, this is all working pretty good. So, in theory, I am listening on the port, but there's no way you can tell. The only way I could tell would be to purposely make it have an error. So that would be one way I could test it. But now what I have to do is do the forking stuff. So I have to first accept the connection. So I'm listening, and when you call accept, this server stops, and it waits for a connection from a remote client. So it's almost like a telephone. It's like you're waiting by the telephone all day long, like you're a technical support center that just sits there waiting for calls. They all come in. When you get one, then you accept it and you hand it off to someone who is going to listen to the person complain about their problem. So we're making the server, and then we will make a child that will listen to people complain about their problems. So I've got my accept up there. That's just a normal Unix command call. I mean, a normal Unix call. And I'm going to throw a little bit of debug logging to make sure I know I got connections. Now, forking. Oh, yeah, let me fix these errors super quick. Missing some header files I need. There's one header file you can kind of just include, and it covers most of your network stuff. The netdb.h file seems to work. But remember, I'm on OS 10, so this might be slightly different on all the different systems. Okay, so I got a connection. Yay, I got a connection. But notice it's not forking at all. So what this server would do is it would just run in a loop and just handle connections from clients and work that way. You could actually develop a large majority of the server with just this one client at a time model and then switch it, because a lot of servers is just protocol handling and calling the right functions and things like that. But I chose to sort of get the forking to work right away so I could later on work on file locking and things like that. If I were to do it again, though, I'd probably just do it as a single client at a time server until I had it all working, and then I would go and use a library rather than forking. Okay, so the client's connected, and I'm just killing it and telling it to go away. I do have a little bug here, though. I believe... Yes, yeah, there, I recognize it. Yeah, so the client was going, and I would accept the connection, and then I would close it, and the client, remember, forking forks that process right where it's at, so it's a clone of it. So it looped back to the top of that while loop and kept on going. So what I have to do is when the client is done, I exit out, because that process needs to die, so that way the server can keep on processing it, handle it, do its wait PID, and be done. All right, now I know that I have to do the handling of the client. And I move the exit out so I can make sure that that still works. And I'm going to put it up in this function. And again, get the bones working. And there we go. And one thing that's sort of nice about forking servers and, the Unix model is when you exit a process, all of its resources get cleaned up by the OS. So in theory, you can be sloppy and leave stuff around, which is just a bad habit. But when you have an error in a forking client server like this, you can basically just nuke it and exit out and be done, and that's it. All right, so now I need a ring buffer because I just want to do an echo. I don't really need to do much. So I'm just making one ring buffer to handle reading in a loop and writing in a loop. And remember, this read sum comes from the net client. So just refer back to exercise 44 where I did that. So I read sum. It's now put in the sock RB ring buffer, and then I write it back. And that writes it, that basically takes it out of the sock RB and writes it to the file descriptor. So notice read sum reads from that FD into the sock RB, and then write sum writes from sock RB into FD. And I just do those in while loops until they quit doing it, and then exit out. Oh yeah, and I forgot that I named this client FD to be a little more reasonable. Do my cleanup that I need to do. I should probably mention that that error has fall through on it. So we'll see if I catch that. Oh yes. And I want to clean up. I don't necessarily have to because this is a forking server. The OS will clean it up. However, let's say I change this to a non-forking server, which would be a very good design decision. The forking server is not such a great idea. Well, I want my code to be clean, so that way when I go to do the new version that doesn't use forking, I'm not running around trying to figure out where the code is. All right, and I got it working. And notice I can do two clients. So see, if you look at the blue bar down in the bottom there, I'm bouncing around between the clients and the server. So now I have two clients connecting. They're doing their thing. Everybody's happy. I only have that one annoying unused parameter that you don't even use, so I just set that to 0. And notice I write a comment to say why I'm doing that. So if someone has to come along and use that, they don't wonder why. Okay, that's all working, looking good. I run the last few things there. Oh yes. So now what I want to do is I'm going to use Git. I'm going to keep track of where stuff is by using Git. And Git is going to make it so that I can fearlessly rip code out and destroy things while I'm kind of building. And Git always has my back. I can basically recover code and do things with it. So a lot of it, remember, it's all about bringing the right gear to climb the mountain. I have unit tests and automated testing that make sure that things keep working as I work on it. So I can make changes. I don't have to worry about it. And then I use Git so I can recover things. And I can also do diffs. So if like I have a bug or something, I can do a diff between the last time it worked and the current time and so on. And so I did echo server. There's that echo server function. I did my client accept. I'm going to throw a little comment in there. I got my forking working. Okay. I'm just kind of doing a quick little code review here. And notice I didn't use non-block function or anything like that, but if I were to change this to use, say, select or something like that, I would want to be able to set those to non-blocking. Okay, and I got my attempt listen working, server listen works, and I believe that should be it. Okay, go on to the next video, and I will see you soon.